Okay, so the last set of suggested questions were from this sheet, the 2 columns. I'd ask you to do all of the first column. So the first question says, what pair of concurrent forces may produce a resultant of 20 newtons? So if you remember from the video from the last day, we had talked about the fact that if you add the 2 forces together, you'll get the maximum possible force that they could create, because it means they're pulling in the same direction. And if you subtract them, you get the minimum possible force they can create, because they're pulling in opposite directions. And then if you orient them any other way, other than completely opposite or in the same direction, you'll get something between the maximum and the minimum. So the set that could produce this would be the set where 20 falls in between when you add them together and when you subtract them. So for A, the maximum force is 15 and the minimum is 5. And 20 doesn't fall between 15 and 5. So set A cannot produce a resultant of 20 newtons. B, when you add them together, you get 40 newtons, the maximum. When you subtract them, you get 0, the minimum, and 20 does fall between 0 and 40. So B can produce a resultant of 20 newtons. Let's check out the others just in case there's 2 answers. C, 20 plus 50 is 70, so maximum is 70, and the difference between 20 and 50 is 30. So the range that set C can produce is 30 newtons to 70 newtons. 20 doesn't fall in there unless you count really weird. So C cannot produce a resultant of 20 newtons. D, maximum is going to be 35, minimum is going to be 25. Again, 20 does not fall in that range. So the only one of these 4 choices that can produce a resultant of 20 newtons is choice B. Okay? Number 2, a resultant of a 7 Newton force and a 12 Newton force is 5 newtons. What must be the angle between them? Well, again, if you think about how you can add them, they can be added anywhere between going in the same direction, where you would add them up, and any other angle all the way over to going in the opposite direction where you would subtract them. Hopefully you notice when you look at 7 and 12 that the difference between them is 5, so they must be in totally opposite directions. In other words, the angle between them must be 180. C, the resultant of 2 30 Newton forces is 60. What must be the angle between them? Well, if you have 2 30 Newton forces acting on the same object and you get a resultant of 60, then they must be acting in the same direction, because 30 plus 30 is 60, so the angle between them would be 0. Number 4, which vector best represents the resultant of F1 and F2 acting together? So here are F1 and F2, and I'm just going to flip it so I can write on this. Okay, so here are F1 and F2, but we can't add them up this way because they're not head to tail. Remember from when we were doing all that drawing to scale stuff in kinematics, you have to place them head to tail. So really, this is F1, and then we're going to slide F2. So where it starts is now, right, we're just going to pick it up and slide it over. So it starts on the tip of F1. And then the resultant is always, always, always starts where the first one started and ends where the last one ended. So the resultant, sorry, the paper keeps moving on me, would be here. This would be our resultant, or our F net. And so then we look down here, which one is it? It's choice C. Okay? Number 5. Which force could act concurrently with K to produce L? In other words, which force of these 4 can you add to K to get L? So L is the resultant. Need to hold it with my... Okay. So L is the resultant here. Okay? So now which one of those forces that are our choices would we add to K? The tail has to start at the tip of K, and it has to end where the resultant is. So which one of those? It's going to be B. Okay? So that's it for the front side. That's all you had to do for the front. The back, I'm going to need paper. All right, so on the back, for you it was the second column. If I had done it in school, I would have, if I had been given it to you, I would have given you a two-sided sheet. But since we were doing it online, I put it on the same side. Okay, so number 1, determine the resultant or net force acting on a stationary elephant by 2 clowns pulling on ropes at right angles to each other. One is 400 newtons and the other is 300 newtons. Okay, so when you're doing a force diagram, we usually just draw a box. I could draw an elephant, but it might be a little scary. So one clown is pulling with a force, it's at a 400 newtons. And the other guy's pulling with a force of 300 newtons. And they're at right angles to each other. But we can't find the resultant because they're not head to tail. So I need to pick up my 300 Newton and I need to move it over. Whoops, imagine that straight, would you? So that it's on the tip of F1. So now they're head to tail. And so now my resultant starts where the first one started and ends where the last one ended. Right here. And I can find that. And the resultant or the net force is what you get when you add them together. And so I can find it by just doing Pythagorean theorem. So square 300, so 9 with 4 zeros. Square 400, 16 with 4 zeros. Add them together, 25 with 4 zeros. Take the square root, and you should get 500 newtons. Right? It's a 3, 4, 5 triangle. But it's a force, which is a vector, so you also need an angle. So now you need to do tan theta, which would be equal to 300 newtons over 400 newtons. Inverse tan of 0.75 is 36.87. And so it would be at an angle of 36.87 degrees WRT with respect to the 400 Newton force. So I'm telling you which one I'm measuring off of, because you could have just as easily moved your 400 one up and found the complementary angle. Okay? So that's number 1. Number 2. Number 2 says 3 ropes pull down on a weight scale. So here's my weight scale. Okay? And 3 ropes are pulling down. One is straight down, and the other 2 are off at angles. And it says all 3 of them are pulling with a force of 200 newtons. And F3 is 200 newtons. And the question wants to know what would the reading in the scale be. And this angle is 30 degrees, and this angle is 30 degrees. Okay? So you're going to have to break the 2 at angles into components, into their x and y components. So this will be F1x, and this will be F1y, and this one will be F2y, and this will be F2x. Now the good news is that for F1 and, this is really 3, isn't it? For F1 and F3, their components are the same, right? So we can find their components. F1x is just the opposite side, so it's going to be, opposite is going to be sine. Oops, so I guess I should probably do sine of 30 is equal to F1x over F1. So F1x is going to equal F1 sine of 30. So F1x is going to equal 200 newtons sine of 30. Sine of 30 is just a half. So F1x is going to equal 100 newtons. So it's 100 newtons going this way. F3x is going to be 100 newtons going the opposite way. They're just going to cancel each other out.